Welcome back to a new video. We cannot learn about different types of classes and the different type of abstraction without talking about interfaces. So interfaces are just another element of abstraction that helps you to provide an abstraction layer to your application. And interfaces and abstract classes are pretty much similar in their aspects, but they differ in their use cases. So by the end of this video, we will have a comparison between interfaces and abstract classes just to clean up the confusion. And now I'm just going to write some comments to have a simple idea between, or a simple comparison between interfaces and abstract classes before we start coding. So whenever you want to define an abstract class, you define abstract class to define characteristics of an object. So for instance, we have a person, and person is an object. And within the abstract class you define how the person looks like, what can he do, what tool is here, and etc. But when you go to an interface, you want to define a common medium that resembles characteristics or actions between two different things or two different entities. So for instance, we have a person and an animal. Both are different, but both need rest. Both can do something, but they are in the end considered to be two different entities. Now, let's start defining our interface to see how it would look like. So to start, you type interface, and here you don't have to add a class because interfaces are considered to be a class, but you just start writing the name. So for example, I'm gonna write machinery here. And now within the interface body, you define the characteristics like the members, functions, and variables. So I'm going to start with making a function, fun start, fun stop, fun charge, and lastly fun fuel. And you can notice we don't have to add the abstract keyword because every function or every member, like functions and attributes, are considered to be abstract. So if you, for example, add the abstract keyword here, it's going to be redundant. So you can delete it. Similarly for any variable, so for example, I'm going to make val name of type string. Now let's inherit from this interface machinery. So I'm going to make two more classes, for example car that implements machinery or inherits from machinery, and class laptop that extends or implements the machinery interface. And as you can see here, the IDE requires us to implement the members of the interface machinery. So here I'm just going to press Ctrl I to implement all the members in the car class. Similarly for the laptop class, Ctrl I, and to implement all the members. Now you could see within our car class. So the car is some type of a vehicle, though it's not related to a laptop because they are two different things. But in the end, they are considered to be a machine, some kind of machine. So car is a machine and laptop is also a machine. Now you could see we have a couple of characteristics for these two classes. So for instance, car can get charged or fueled, but not both, because if it was an electric car, then it should get charged, and if it was a regular car, it should get fueled. And even though for our laptop here, so our laptops can get charged, but it cannot get fueled. So for that, some characteristics here are not needed in our classes, for instance, the charge and the fuel. So for interfaces, you could implement or define a default implementation for the members that you don't want to override or you don't want to be forced to override. And as you noticed before, we are forced to implement all when you press Ctrl I. So we, for example, in the car, we don't need the charge because the car is a regular car, and within the laptop we don't need the fuel, we only need the charge function. So for that, we are going to have a default implementation within interface to make them optionally to have the option to override them or leave them. So the way to do that, just add empty body to the charge or the fuel, and whenever you're going to implement them again, you would see you are forced to implement only 3 functions or 3 members, like the name, start, stop. Similarly, in the laptop, you are forced to implement only 3 members, and whenever you want to implement the, let me just mute this, whenever you want to implement the option, whenever you have an option to implement these 2 functions, you just press Ctrl O, and here you have fuel or charge. So you have the option to choose what function suits for your class. So in the laptop class, we need the charge function, and in the car class, we need the fuel function. Ctrl O, the fuel function. And you can see here, the compiler added the super.fuel as it calls here. It calls the parent function, which is the fuel, which has an empty body here. Now, what we're going to do is just to implement these functions within the car class first, then we're going to move to the laptop class. So the name of the car is just going to be a car. Starting a car, going to be println starting a car. Similarly for the stop function, stopping a car. And lastly, the fuel function is going to be fueling a car. Fueling here, yeah. Great. Now for the laptop, so the name of the laptop is going to be laptop as well. And for the starting, so println laptop has been started. The stop function, laptop has been stopped. And lastly, the charge. So we don't need to call the parent implementation. We only going to define our own implementation. So the charge laptop has laptop is being charged. Now, as we have said, when you want to have the option to implement the function or not within your class, you would see that the compiler gives you help on that to differentiate between the function that you are forced and the function that you have an option with. So if you see that we have a default implementation for these 2 functions here, and we see that we have a blue, some kind of circle in the left hand side. And for the function that you are forced to do, or the members that you are forced to implement, like the name and the 2 functions here, they are annotated or marked with this green circle here. Now that's great. Let's just create an instance of our classes. Before creating that, let's try to create an instance of our interface. So here I'm trying to make an instance of my interface, val I equal to machinery. And as you can see, we have an error because classifier machinery does not have a companion object and thus must be initialized here. So you cannot implement or you cannot create an instance of an interface directly here. Even if you add a constructor, you would have the same error because you need to make an instance of a class that implements your interface. Now, for that, I'm just gonna make an instance of the car and laptop classes. Car equal to car, and open the constructor, then val laptop equal to laptop. Now let's try to call the functions. So val car, yeah, I'm gonna print the car name. So println car.name. Similarly for our laptop, and then we're gonna call the functions. So car dot start, car dot stop, then lastly car dot fuel. Then the laptop, so laptop dot start, maybe stop, yes, laptop dot start, and lastly laptop dot charge. Now let's run the program to see the result. So here we have the car, the machinery or machinery's name, the car and laptop. Then we start and stop and fuel the car, starting the car, stopping the car, fueling the car, and then the laptop's being charged, started, stopped, and charged. Now let's have the comparison between abstract classes and interfaces. So for that, I made a little table here, you could say, to show the differences. So here we have our abstract classes. So abstract class can have an abstract and non-abstract members. And as you can see here in our abstract class here, so we have abstract members and non-abstract members as well. So this is abstract, annotated with abstract, and these are not annotated with any abstract. So we could do this. For interfaces, only abstract members unless a body was defined. So if you go to our interface here, which is a interface, these are considered to be abstract by default. And whenever you define a body for your function, for example, it becomes non-abstract and you are not forced to implement it, as we have seen in the beginning of the video. So for abstract classes can inherit from classes and interfaces, but for interfaces they only can inherit from other interfaces. So let's try this. So here I have my abstract class and I will make it inherit from B class. And as you can see, we don't have any errors. Just add the constructor of the B class and you are set to go. Here also we are going to implement our interfaces for A interface and B interface for our class. So A interface, we could implement interfaces. B interface, we could implement interfaces for abstract class. However, for classes or for interfaces, so interfaces can only implement or inherit from other interfaces. So I'm going to make my A interface implement or inherit from B interface here. See, everything works, but whenever you're gonna inherit from an abstract class, you're gonna have an error saying that you cannot inherit from a class. So an interface cannot inherit from a class. Cool. Let's go to the table. Now we have an abstract class can have protected, private, functions, and attributes. For interfaces, only public attributes and functions. So if you see here in our class, it can have a private or protected members. It works. But for our interface, you cannot have private or protected members. And note also one thing, that you cannot assign a value to your attributes directly in an interface. So here you cannot assign a value to an attribute directly, and this will cause us an error. If you try this, see here we have an error saying that you cannot initialize the property. As an alternative, you could provide the get initializer. So the get initializer is allowed, but initializing it directly is not allowed. Cool. Now with the abstract classes. So abstract classes can have constructors. So here we had a constructor for our A class. Similarly, we could add the constructor for our B class. But for interfaces, interfaces cannot have a constructor, and adding the constructor will cause a syntax error. So our interface here, add a constructor, you see, cannot add an constructor for our interface. So now we have reached to the final part, when to use abstract classes or when to use interfaces. You would usually use abstract classes when you want to define the characteristics, as we have said, or how the object would look like. So this person is tall, is short, this animal is green, yellow, or whatever. And for interfaces, you would use them usually for defining the functionality. So does this animal run, or can this human jump? And as a quick example, I have two abstract classes here, and both have two related attributes or two related members to them. So for the animal, we have get type, what kind of animal, and also the name. For the person, we have get job and the name. And you can notice here we have common members or common functions like the run and walk. So both animal and person can run and walk. So instead of having that, or instead of having the same functionality in both places, so we just wrote the same functionality in two places, let's just define them in one place and make our classes inherit that one place. So that one place is going to be an interface. So instead of having run and walk here, I'm just going to define an interface called can run and walk. And now we provide our functions, or we write our functions, fun run and fun walk. Now we make our animal have this functionality, can run and walk. Similarly for our person class, they have the same functionality. And notice here, it doesn't require us to implement them, as this is an abstract class and not a normal class. But if you make it a normal class, you are required to implement them. But now to implement them on purpose, we would use Control I, and here we have our functions. So you can notice how the code is much convenient and cleaner, because we wrote it once and we used the functionality over and over again. And whenever we have another class, for example, called abstract class, for example, alien, then the alien also can run and walk. So we can also have the same functions here and without even writing them twice. So you have seen how the interfaces just provide us with a convenient way to spread our functionality to more than one class. And with that being said, we have reached to the end of the video. I hope I didn't spread so much confusion about this, because the difference between abstract classes and interfaces has been a great debate since the beginning of the programming languages. So thank you for watching, and I hope I see you in the next video.